Hello and welcome to our first episode of the York Universe podcast for 2026. You are listening to York Universe, the astronomy and astrophysics podcast, written and presented by the students, faculty, alumni, and friends of the Allan Carswell Observatory at York University. You will now find us wherever podcasts are distributed. I am Mary Armour. I am one of your hosts this evening, and I am joined by Paul Mackin, and Patrick Hall. We are broadcasting live from the Allan Carswell Observatory located at the Keele campus of York University in Toronto, Ontario, Canada. We broadcast live every Monday at 9 p.m. local Toronto time, or currently 1 a.m. Tuesday Universal time. You can find the link at York U Observatory from the York U webpage. We are running in concert with our online public viewing, who produce the visual part of this that you'll see on YouTube. We also call it our OPV. The feed is run by the observatory staff. Unfortunately, tonight, I do not believe we are doing live observing because the weather is not particularly helpful, which is pretty common at this time of year. So the observatory staff will be putting up some great images that have been taken on previous nights. To navigate to our live show or find out more about us, please check out our website at yorku.ca/science/observatory. And you can find the link to our online public viewing chat on YouTube. Any questions or comments you may have on past shows or suggestions for future topics, please send us an email at observe@yorku.ca. You can also connect with us on Instagram with the handle at YorkU Observatory, or on Facebook at Allan I Cars Web Op. All of our programs are free, but if you would like to make a donation, we will certainly appreciate that. Again, if you go to the York University Science/Observatory webpage, you can find the link to make donations. And as always, we will be monitoring the YouTube chat for any questions and to post some additional comments or possibly links to interesting web pages. Right? So tonight we have with us again Paul Mackin, who has been, of course, a regular, and we welcome Dr. Pat Hall, who is sort of here for the first time joining us. So as usual, we'll start with our This Week in History. So I will go, I'll start first. And of course, women in science has had an interesting history over this century. And on January 13, 1978, NASA finally selected its first female astronauts. And amongst that group was Sally Ride, who, of course, was the first American female astronaut, although she was only the third woman into space, following two earlier Soviet cosmonauts. So the Soviets were, a fair bit ahead of the Americans in training female astronauts. Uh, this was quite the thing at the time. Sally Ride was actually relatively young when she was selected as an astronaut. She had a background in physics and was sort of one of the younger astronauts, male or female, ever to end up going into space. I was just old enough to kind of remember when this was happening. Um, but it was in the news quite a bit at the time. I don't know, Paul or Pat, do you remember anything about some of this when it happened?
Well, I can jump in and say that there was a documentary film that came out last year just called Sally, and I saw it as really good. I recommend it to anyone interested in space history or Sally Ride herself. I
I've
do.
seen it as well. It's an excellent documentary. And yeah, I actually do remember her being selected, and it was quite a big deal at the time. Which, looking back on it, it seems quaint, I guess, maybe, but because now women play a very a prominent role in the space program, and we'll hear more about that later today, I think. But it's it was really a big deal at the time. People were kind of flabbergasted, and the Soviets had done it early on. Now, their first cosmonaut was basically done as a political showpiece in the Cold War, but it's now become much more accepted and standard. You can't imagine it otherwise.
I mean, I guess, like as a female, you tend to follow some of the history of sort of astronomy and space flight from that sort of perspective a little more. And, even not that long before that, 20th century female astronomers and female physicists were not getting maybe the recognition they should have. Um, and credit was taken in science in general by their male supervisors or colleagues. So I think it was in the 60s and 70s when this sort of stereotype really started to break. And this was probably a very public way, because Sally Ride wasn't the only one. I think there was a group of 7 of them that were actually chosen, and some of the, some very qualified individuals, certainly as qualified in some ways, if not more so, than their male counterparts at the time. Unfortunately, this also led to the very, shall we say, publicity stunt situation with Krista McAuliffe as sort of the teacher into space, which of course ended very badly. But at least when NASA selected their first female astronauts, they were definitely selecting them on the basis of, their qualifications and, their, I guess, skills and knowledge to go into space. Particularly in this era, you're really looking at the space shuttle at that time, because there weren't many other ways that Americans were going into space really by the late sort of 1970s. And they did make quite a big deal of it at the time when, Sally Ride was finally launched that way. So,
It's also worth remembering that there was a group known as the Mercury 13, 13 women who underwent some training in the 1960s. But this First Lady Astronaut Trainees flat was eventually canceled, I believe, because there was an administrator at NASA who simply said, no, we can't have women astronauts. So that was the 1960s or early 1960s. And then 15 years later, in 1978, Sally Ride was selected. So things changed quickly, but not quickly enough.
yeah, it's that era is interesting. I mean, at least in the 1960s, they thought about potentially training female astronauts, which is more than you might have had a few years earlier. But it probably did eventually lead to this group of, I think it was 7 of them, being chosen and finally, actually putting women into space. But the 70s was really a decade of change in a lot of ways, and a lot of technological change. And it's also, of course, when the Americans went from, some of the grandiose Apollo and projects to sort of pulling back and focusing on the space shuttle, which a lot of people in hindsight think may have been the wrong path to go down. Um, Although it certainly had its benefits. But so Paul, I think the next news item we're looking at is interesting because it relates to one of your items later as well.
Yeah. So it wasn't quite this week. In fact, it was last month. So on December 11th, 1972, the Apollo 17 lander Challenger touched down in the Taurus Latrobe Valley on the moon, marking the last manned mission to the lunar surface so far. Astronauts Gene Cernan and Jack Schmitt, um, who was the first scientist to walk on the moon, Schmidt was, stayed a little longer than 3 days, conducted 3 spacewalks, returned over 115 kilograms of sample material. Meanwhile, astronaut Ronald Evans remained in orbit in the command module America, that was the name of the command module, capturing detailed imaging of the lunar surface, which was actually captured by a camera mounted inside the the service module. And on the way back, Evans had to go on a spacewalk and pull the film canister out and bring it back into the spacecraft so it could come down to Earth. Now, Apollo 17 was originally going to be one of the J missions. These were science missions with extended stay. They were science focused. They had a rover to enable more distant exploration. And it was all those things. But budget cuts at NASA removed Apollo's 18 through 20 from the flight roster. They actually had the hardware, or almost all the hardware, I think. But they were cutting the budget, and they decided that, Apollo 17 was the last, and public interest certainly quieted down. But in terms of mission accomplishments, Apollo 17 did very well. The regolith was explored. They took up a device to basically project an electric wave into the surface of the regolith, and they could check for water. They didn't find any. They did find volcanic soil, which was a key mission objective. The rover itself traveled over 35 kilometers in 4 hours of driving. And there's actually a great video. Before they took off, they parked the rover. They'd attempted to do this with the other missions that had a rover, 15 and 16 as well, but they parked the rover, and they had a controller on Earth pan the camera as the upper stage of the Challenger took off, and it pans as it goes up into space. And it's really quite great video, but it was the only one they were able to actually get the panning to work properly. So, but just before they left, the astronauts took a call from then President Richard Nixon, who referred to Apollo 17 as being the last visit to the moon, quote unquote, this century, the 20th century. And sadly, he was correct. Now, I actually there was a documentary about Apollo 17 and astronaut Gene Cernan that was released, I don't know, maybe about 10 years ago. And I went to a premiere of it in Toronto, and Cernan was there. And during the Q&A, he was asked about that. And he said, of all the things that happened on the mission, only thing that made him mad was hearing Nixon make that reference to the last moon visit this century. It's now been 53 years since Apollo 17, and nobody has gone back. But that may be about to change. And we'll talk a bit about that later.
Yeah. So it's like I said, that was such an interesting era, and in some ways there are some uncanny parallels going on now because NASA is making cuts and cutbacks. They're still trying to get to the moon, but I think we heard this week about how, or in the last week or two, about how they're cutting the sample return from, I think it was Perseverance. That sort of planned sample return has kind of been canned, as well as a couple of other potential missions have kind of been pushed onto the back burner or just canceled because they're trying to sort of cut back on the budget everywhere. And it's kind of sad because a lot of work has gone into some of these missions, and to sort of can them at the last minute is almost even a stupider use of money because you've poured all this investment into it, and then at the last minute you can decide, well, no, we're not going to do it after all. We've poured, all this money into it, but we'll save ourselves a couple of bucks by not finishing it. I never understand that attitude.
It's absolutely the truest thing in the world that the space program in the U.S. is, and in other countries, is highly political. The ESA's got a slightly different approach because it's not. It's really given long-term funding, whereas in NASA the priorities change every time there's a change in administrations, and administrations are focused in 4 or 8 year timeframes. So it is a challenge, but they've funded a lot of the Artemis program that we'll talk about, but there's some challenges with that because they don't really have a solid architecture for it, and They've cut back enormously on science. So they, rather than the budget being cut, it's been cut a little bit, but they've moved things around and maybe moved them in the wrong direction. But we'll talk further about that, I guess.
Yeah.
Yeah, it's the headline from Universe Today is NASA's Mars sample return is dead, paving the way for China.
Yeah, yeah, it's a
Yeah,
tragedy.
and it's sad because it's being cut. I don't know, political reasons. They think they can. I don't understand it because when you've put that much work into something to suddenly can it at the last minute, it's such a waste, right? It's such a waste because you've poured all kinds of resources into it and you don't want to do the last little push to get it over the line. It just, ugh. But
Yeah,
yeah, no one ever said there's like, yeah, I think you're right. The ESA funding model has been a little bit more logical, but it doesn't depend on the politics of a single country
exactly right.
anymore.
Yeah, it's a centralized planned resource for all of Europe. And I mean, maybe because ESA was going to be part of that sample return, maybe they'll pony up and try to do it uh, rather than partly. Maybe they'll do a lot more of it. We'll see.
Yeah. Well,
Yeah.
it's interesting because, like some of the chatter was, oh, well, maybe a private space company will pick it up. I'm like, private space companies are barely able to get something to the moon and they can't even land that successful. How do you think they're going to get something to Mars?
Yeah,
Yeah, it's the under they people don't understand sort of the length of planning and stuff that goes into it. I would not be surprised if a different country makes it there first and actually takes the Perseverance samples that are
yeah,
already there. I'm sure that would frost the Americans to no end, but I could see that happening. Um,
yeah.
that'd be a bit of a political coup. Uh,
Well, the good
um,
news is the samples aren't going anywhere. They're
yeah,
in canisters, and again, the space program in NASA particularly is administration based, and according to the U.S. Constitution, the current administration has one term now. So
yeah. Well, we won't get into that one. So moving on to some more recent sort of history news. Uh, talking about launches, um, one of my fascinations has been exoplanets and exoplanet missions ever since I first learned about the Kepler mission as a sort of concept decades ago. And we're now sort of getting to the point where NASA, just in the last, I think, 48 hours, has launched the Pandora mission to study exoplanet atmospheres. And this was an interesting one because this is sort of another one of the programs they've started, and this is using sort of smaller satellites. So they talk about Pandora being the size of a refrigerator. I mean, given how refrigerators range in size, that could be, somewhat variable, but it's a relatively small satellite. And the point is, it's going to have about a 20, I think they put it as an 18-inch telescope, and they're hoping to look at 20 previously found exoplanets and try and look for their atmosphere because the detectors on board this thing are aiming to see and sort of study through a couple of different methods what's in the atmosphere. So is there cloud? Excuse me. Is there haze? Is there water? What's the composition of these atmospheres? Some gases you can see, some you can't. Nitrogen is incredibly hard to detect remotely. Um, but this is sort of a serious attempt to start finding out about the conditions on exoplanets. Whereas, 20 years ago, when you were sort of sending out Kepler, it was just about finding potential exoplanets. Now we've gotten to the point where we've just launched a mission where you can actually start to study the atmospheres of some of these bodies. I mean, James Webb has given us some hints, and some other observations have given us some hints, but this one is that's sort of particularly focused on it. So it's quite, I think, an interesting mission going forward. So,
Yeah, and I think it's very interesting that such a small satellite can make such a big impact because some of the stars that host these exoplanets are so bright that you don't really need a big telescope to study them necessarily.
yeah, if it's close enough by, the
Yes.
smaller telescope will do the job. just fine. And it's like I said, this I guess they call them CubeSats sometimes, is sort of the way they're going with a lot of these things is, smaller is better. And it reminds me a bit of the Discovery series where I think Pathfinder was the first, really big splash they made with that, where the idea was, okay, let's scale down in cost, rather than these, billion-dollar things. They were aiming in that a much smaller price tag, and more focused missions. This is kind of a similar thing, but now they're looking at doing it from small satellites, which will also imply, I think, small budgets. But again, it's this sort of, I think, shift towards efficiency and how much, bang can we get for our buck with sort of some of the scientific exploration, because anything space related is very expensive. But the good news is that some of these missions produce so much data, you're going to be able to use it for decades, right? I mean, Kepler produced such a massive amount of data that was useful not just to planetary sciences, but people looking at variable stars and a few other things. So sometimes these missions have a lot more benefit than maybe the original intent of them is. So it'll be interesting to see like what Pandora ends up collecting and how much it can actually tell us about these atmospheres. So it's going to be an interesting one. So I think our next topic then, is one that you had, Pat, for like recent news.
Yes, the American Astronomical Society had its annual meeting, its annual January meeting last week in Phoenix, Arizona, I believe. And two of the news items from it that caught my eye, one of them was data from the Vera Rubin Observatory, which is just getting set to scan the sky every night from Chile. So it'll scan every clear night as much of the sky as it can reach in, I think, 6 different filters and produce a huge amount of data. So they have released some early science data of near the Virgo cluster. And one of the things that this group did with the data was to look for asteroids. And it's not just a matter of finding asteroids as streaks in the data, because the asteroids aren't moving at the same, or they are moving relative to the Earth and the Earth's rotation. If you observe a point in the sky, you'll be moving your telescope to make sure that you observe the same part of the sky, but the asteroids will zip through your field. So that's reasonably easy to detect, but the Vera Rubin data is so good that they can actually measure how the asteroids are changing in brightness. So the streaks may be a little brighter and fainter as the asteroid rotates. And they found some real record-breaking cases. The record-breaking that they found was the asteroid 2025 MN45. It's estimated as 710 meters in diameter. So that's a reasonable size for an asteroid. And it spins 360 degrees in 1.88 minutes. So its day, technically speaking, is only 113 seconds long. So if you're sitting on the asteroid, you're going to watch the sun rise and set about every minute. Stars move at 3 degrees per second on its equator. So it's really crazy to imagine. And this is certainly not one of the rubble pile asteroids that we think are out there now. And if you remember the images of Bennu, the asteroid, it looks like a rubble pile. Not this one. This is a solid chunk of rock to be able to spin that fast and not fly apart.
Yeah, it's fascinating. Like, I guess in astronomy, we're used to it, but every time you get a new telescope and every time you get new technology, you get this whole sort of, you know, I guess initial sort of surge of new discoveries. So what could come out of Vera Rubin, um, over the next year could be fascinating. I mean, I mean, if you think about even like back in the 90s when CCDs first came out and the sort of surge in what you were able to do,
Mhm.
from finding exoplanets to everything else, it was such a huge bump to astronomy. And you wonder what, Vera Rubin, just because of the nature of the observatory, it's not something we've really seen before, where you have this sort of massive ability to scan so much of the sky and collect so much data every night. And I don't remember the exact number, but Chile has an awful lot, where it is has an awful lot of clear nights. So it shouldn't be too badly affected by weather most of the time.
Oh
But
yeah, probably, yeah, 2/3 of the nights will be clear and probably, more than that will be usable. So yeah, it'll be really amazing. I'm sure we'll find different kinds of stellar explosions that we're not familiar with right now. Uh, yeah, it really boggles. And I think they found a couple other asteroids that are rotating almost as fast as this one. Um, so yeah, it'll be very interesting to see what kinds of asteroids they find and what kind of explosions they find. Yeah, it'll be amazing.
yeah, and part of me, it boggles the mind, like what the heck set an asteroid spinning that fast? How the heck did it end up going that quick? Um, I
That's
think,
true. It's a good point. I mean, we know that some asteroids form so massive that they're hot enough that they differentiate inside. Everything melts and the heavy stuff sinks to the center, and then that asteroid collides with something nearly as big and shatters into pieces. So maybe this is really a remnant of one of those early massive collisions.
yeah, it's like I said, things like this will open so many sort of questions to be addressed. Like it's just it kind of boggles the mind that something could spin that fast.
Yeah.
Um,
So that was one of the items that caught my attention. The other one was something much earlier and more distant in the universe, from a time only 1.4 billion years after the Big Bang. So when the universe was only 10% of its current age, and a telescope in the southern hemisphere found some time ago a galaxy cluster at that age. This is one of the highest redshift or most distant galaxy clusters known. And what this is an area of the universe where there was more matter than average, quite a bit more matter. And so galaxies form, but a whole bunch of galaxies form near each other, and their gravity starts pulling them together. And so they're pulled towards each other, and the gas around them collides and shocks and heats up. And so we can look today and see the Virgo cluster, the Coma cluster, other clusters around us that are relatively nearby, and other impressive clusters in our somewhat older universe. But this galaxy cluster, when the universe was so young, it's already amazing to have detected it. But what they found was the galaxy is 5 to 10 times, excuse me, the galaxy cluster is 5 to 10 times hotter than expected from just gravity. So you can predict how much mass there is, how much the gravity will pull things together and collide and heat up the gas. That produces a certain temperature. This is much hotter, like I said, 5 to 10 times. So really unexpected. And if you look at the plot they have, it's just a crazy outlier, as they said in their press release. Yeah, at first we didn't believe the data, but we went back and double checked and triple checked, and sure enough, it's real. And the likely explanation is that the uh, inside this cluster, the galaxies, some of them are known to be active galaxies, which means they have an accreting supermassive black hole at the center, and that accretion down at the very close to the black hole can result in matter being flung out from near the black hole at nearly the speed of light. And so if you have these jets or winds of material with incredible energy and momentum flying out from near the event horizon of these supermassive black holes, that can actually deposit a lot of energy in the galaxy cluster and heat it up. So there had been some hints of a process like this going on. I don't think anyone expected it was so extreme. And maybe they even say this is the most extreme cluster we found in out of 25% of the sky or something like that. So it may be a real outlier, but it's still amazing to see how, like with James Webb, the universe is much more active when it was young than we would have thought even just 5 years ago.
Yeah. But I always find it interesting, and I sometimes try and make to the point to some of my students in class, like, you've always got that graph and you have that one outlier and you want to chuck it out of your data. But in the end, it's these outliers in the data that lead to some really interesting discoveries. So this idea that, okay, well, I should smooth everything out and I'll, just pretend these outliers don't exist. You can lose so much in science because it's these like really weird things that lead to some very interesting discoveries, which is why I always laugh at these people who like over process and statistically analyze and flatten out all their data. It's like, well, if there were some interesting outliers in there, you just lost some really incredible discoveries. Um,
Yes. What's this? Some mold growing in my sample dish? I'll just throw it out. Oops, you didn't discover penicillin.
yeah, it's and it's the recognition that, like, what is this outlier actually mean? Not, oh, well, it's just an error in the data, which sometimes it is. But you can't assume that because if you do, you lose so much, right? And I think, when you're talking about students doing labs or doing those kind of things, you try to make the point to them that, like, look, if you get an outlier, sometimes it's a mistake, and sometimes it's an unexpected result that points to something pretty amazing, whether it's penicillin, whether it's these, really hot galaxies and understanding what was going on early in the universe. It's like you can't just ignore that, and people are guilty of too many, I think, statistical, oh, I want to make my curve look nice and smooth and everything. It's like, no, that's not how the real world works. So I always worry when people try to ignore these kind of things. Yes, you have to go back and double check them and everything to make sure it's real, but this is where like the really incredible breakthroughs I think come from sometimes. So,
Yeah, absolutely true.
so we're about halfway. So just some reminders. You are listening to the York Universe first broadcast of 2026. We're broadcasting live from the Allan Carswell Observatory at York University in Toronto, Ontario, Canada. Please check out our website at yorku.ca/science/observatory. And you can join the chat that is live on YouTube right now. If you want, if you can post questions you have there, or if you have other questions about content. Again, tonight you are listening to myself, Mary Helen Armour, as well as my co-hosts Paul Matkin and Pat Hall. A couple of other reminders. We are having our first observatory tours back again, starting again this week. So this January 14th, we will have our observatory tour from 6 to 8 p.m. And our OPVs, of course, have resumed today too. Okay. Another reminder, and I think they were going to put the link in the YouTube chat. Our annual observatory calendar is now available for sale, and it can be found at the York University bookstore, as well as a lot of other interesting observatory swag. And part of the proceeds from this do go to help supporting the observatory. So normally we just do some news and some history, but being this is our first episode of the year, we thought we'd also bring in a few topics on what some of the upcoming and potentially really fascinating observatory or sort of astronomy type topics or space travel type topics might be for this year. I mean, I know a lot of observers are sort of, keeping their eyes peeled for whether Core Bohr will go nova. They've been talking about this for a few months. It's due for sort of a outbreak or whatever you would call it, another event where the nova flares up again. So that's potentially one, although we may never know when it happens. Of course, we're always happening to hear about, potentially new comets or other sort of, objects of this nature that are somewhat unpredictable. So it'll be interesting to see what 2026 brings in this way. But I think, Paul, you had another sort of topic looking at space travel for this year.
Sure. So, yeah, I mean, tying on to our Apollo 17 story, it's been 53 years, but Artemis 2 is going back to the moon, and sorry, Artemis 2 is going to the moon. We are going back to the moon, and when I say we, I mean Canada in this case. Following from our previous item on lunar explanation, there's a new Cold War. The Cold War between the Soviet Union and the U.S. was really a big driver in the moon race. Well, now there's a similar one going on between China and the U.S. and its partners. Um, and China's laid out a they're not the most open about it, but they seem to have laid out a pretty systemic approach to which should see humans landing on the moon around 2030 or thereabouts. So NASA and the US government have responded with a stated intent to get to the moon first and then go to Mars. Um, but the approach and details of NASA's plan are still pretty vague and highly malleable, I think. But the first step is defined, and it's going to take place next month uh, with the launch of Artemis 2. It'll have four astronauts, three Americans, two men and a woman, and one Canadian. And it's going to be launched in they're going to go in the Orion spacecraft, which is kind of a descendant of Apollo with better avionics, I guess. And it's a bit bigger, and it's going to be launched with a space launch system, and it'll journey out to the moon and then return. It's not going to land. Um, it's a pretty simple sounding flight plan, but it's actually quite complex. They're not going to orbit the moon, they're going to go around it. They're doing kind of a bit, they're not going to be aligned with the lunar equator because some of the goal here ultimately would be land near the South Pole. So the flight plan is they launch, they spend kind of a day in orbit checking out the spacecraft because no humans have flown in the spacecraft and no humans have launched on the Space Launch System, the SLS, before either. So they're going to check all that out. Then they're going to kind of make their orbit a bit bigger, and then they're going to fire translunar injection. They're going to go out and they're going to go about 10,000 kilometers, I think it's about that number, behind the far side of the moon away from Earth. Then they're going to go even a little further out. They'll actually be the furthest, this will be the furthest humans have ever been from the Earth. And as I said, there's a Canadian point here because one of the astronauts, a mission specialist, is Canadian Jeremy Hansen. He's from London, Ontario, and this was part of Canada invested in this program, and as part of that, we got a seat on the not the landing, but the first mission back. Now, the next phases of the Artemis program have been funded, but the actual approach is very highly dependent on either SpaceX's Starship or Blue Origin's Blue Moon, both serving as either serving as a lander, and neither of which are ready for anything approaching delivering people to the moon. SpaceX is further along, it seems. So we're also going to be watching subsequent test flights of Starship and Super Heavy this year. But this is this is an exciting story, and I think we're all going to be watching it. And go Team Canada! We're for the first Canadian is going to go a really, really long way away from Earth, further than anyone else has gone.
Yeah. I mean, there are some other Canadian connections with this too, because the South Polar mission, they're looking at the people helping to decide on landing locations and some others. There are connections here. Of course, Gordon Osinski down at Western has acted as an advisor on some of this as well from a geological perspective. And I know I was at the what's called GACMAC, the Geological Association of Canada uh, conference last spring, and they had a number of presentations about sort of the Canadian connection and some of the work they're doing in mapping sort of the South Pole and helping to find potential landing spots and evaluate them, and some questions about like rovers and stuff. So Canada is actually fairly involved at this point with this sort of return to the moon aspect. So.
Yeah,
And
but
Paul,
there's a lot of things we don't really know. Sorry, Pat, you were going to say something?
oh, I was just going to ask if you know whether Jeremy and the other astronauts going around the moon on this trip are likely to get a chance to join one of the missions in the future that actually land on the moon.
Well, right now the plans, and I put the word plans in question mark, in quotation marks rather, are really vague. The first mission, Artemis 3, that should land 2028 is the current date, but you know, check back in often. Uh, would probably not have any of this crew, but then there's 3, 4, and 5 are defined as missions, and I think there is a good shot that one of these astronauts would go on those missions. So we could see, and Canada's got a pretty robust astronaut corps, and we've got good history with flying with NASA. And actually with the Russians on Mir and whatnot, but and on the International Space Station. But the I think we could see a Canadian, but I don't think we'll see them on the first mission.
Yeah, I have to wonder if the astronauts are, really eager to make that second trip for them and actually land on the moon. I know there were astronauts in the Apollo program who, flew around the moon but never landed on the moon. But I'm pretty sure that if you'd asked them, they really would have preferred to also land on the moon.
Yeah.
Oh, for sure. I mean, so would I.
That's got to be the sort of ultimate in disappointment of I got almost all the way there and didn't get to walk on the surface.
Well, can you imagine? My favorite is Jim Lowell, who was was one of the first 3 Americans to orbit the moon, was actually considered as the lunar module pilot for Apollo 11, and Buzz Aldrin beat him out on that. Then got command of Apollo 13. Apollo 13. uh, you know, um, trivia question: if you ever want to play trivia, can you name one astronaut that both orbited the moon on one mission and walked on the moon on another? There's actually a couple, but just name one.
Yeah, I
Um,
couldn't.
I know
Gene Cernan from Apollo 17. He was the lunar module pilot on Apollo 10, which was an orbital mission as well. So,
yeah, I know it's not Michael Collins who orbited an Apollo 11, I guess it was.
yeah,
The first mission, but despite being the first to orbit, he didn't make it to a later mission to actually walk on the moon.
yeah, he announced his retirement almost immediately after that mission, actually. So,
Yeah, well,
yeah, so it's
okay. He took himself out of the running. That's fair.
So, yeah, Pat, you're going to talk about one of the great telescopes going up this year, though.
Yes, scheduled to go up this year. So fingers crossed and knock on wood that it stays on schedule. But this is the Nancy Grace Roman telescope, named after the early NASA pioneer. It's planned for launch in September. It's the size of the Hubble telescope. And if memory it's actually very similar to Hubble. I think this is sort of a spare telescope that the United States military had. They launched a satellite very similar in size to Hubble, the telescope. Before Hubble, it was just pointing down at the Earth for, Earth observing reasons. And then sometime after Hubble, I think in the late 1990s or early 2000s, they announced, we have this spare mirror, which we're never going to use. So maybe you astronomers would like to use it. And so here we are in 2025 with, 2026 with this telescope going to launch, same size as Hubble. So we'll have the same sharpness as Hubble in terms of its view, but it will have a much bigger field of view than Hubble does. It will have a real imaging capability that's not the tiny or relatively tiny postage stamp, even of the latest Hubble cameras. So this is really designed to be a wide field survey telescope with image quality as good as Hubble. So it won't record in the ultraviolet, which is something, a capability we'll lose once Hubble is decommissioned. At least we'll lose for a decade or more until we have some replacement up. And Canadians have some ideas about that. This Nancy Grace Roman telescope will have filters that will let it record light from green wavelengths, yellow, orange, red, and far beyond into the near infrared. So what we call the near infrared from the ground will be done from space in these different filters, which will help us figure out when we look at an area of the sky, how distant the galaxies are, whether something is a quasar or a star. And the fact of getting so much imaging at Hubble resolution, it'll be really amazing to just see details of distant spiral galaxies, to be able to look for gravitationally lensed galaxies at a much better resolution than you can do from the ground. This will provide a real amazing capability. It has a couple different surveys defined, as is usual with these wide field surveys. It's called a wedding cake strategy. So where you cover a large area of the sky, maybe just once or maybe twice, and then you do a smaller area several times, maybe half a dozen times, and then you pick one area of the sky and image it over and over again so that you can look for transients. So a supernova explodes and you can trace its evolution, or something unusual, some gamma ray burst, some tidal disruption event where a star wanders too close to a supermassive black hole and gets torn apart, forms an accretion disk and flares up. All these kind of transients are visible when you observe over and over again. And so the last point to make about the Roman, as it's being called, is that in just 1 month, it will generate about twice the data volume produced by Hubble over 30 years. And I worked that out. It's about 11 terabytes of data per day. And I don't know if 11 terabyte drives are available, but they probably are if you pay enough. If you just imagine getting a 11 terabyte drive on your desk every day, that's the data coming in from this telescope. So it's a very different way of doing astronomy than it used to be. It's definitely something where the data will be stored at the Space Telescope Science Institute, and you'll work by sending computer queries to the Institute to query the data set as it sits there. It's not a case of downloading the data to even your big computer. You'll be hard pressed enough just to download the catalogs.
Yeah,
Yeah, go
I,
ahead, Mary Ellen. Sorry.
I had an odd, like, it's an interesting question because I wonder about the mirror quality as compared to Hubble, because of course Hubble always suffered from the problem that the mirror was not properly shaped and they had to basically give it glasses very early on in its mission. So it
It's
may
true.
it never quite reached the resolution they had originally thought it was capable of. I wonder if this mirror is actually, I guess, true, I guess you'd call it the proper shape. So you
Well,
wouldn't have that issue that you had with Hubble. I wonder how much that might contribute. Or is the quality of the mirror not quite as high because it was produced for military purposes rather than scientific ones? I don't know. That'd be,
it's
I think, something be interesting to know.
it's a good question. I am sure they tested it within an inch of its life to make sure they didn't have the same embarrassing mistake as with Hubble. Yeah, my
Yeah.
understanding with Hubble is that it got eventually to the same sort of core resolution, but there's more, let's just say, scattered light in the wings. So it sees the images. It's kind of like having smeared glasses. So you can still see things sharply, but there's just a little bit of haze around everything. I'm pretty sure with this telescope it will be better, but it's a good question and a good point that it will be the same size as Hubble, but somewhat better image quality than Hubble, because this mirror will not need glasses, as you put it.
At
One
least,
of the things, sorry, go ahead.
no, go ahead, Paul.
I was going to say one of the things I'm totally fascinated by, and this is something I worked in remote sensing on satellite, Earth-facing satellite stuff years ago, and even this was in like 1991 or so, and even then we had huge storage problems, and not only that, data access problems, how to actually access data, just from the amount of information we were getting daily, and now with you've got Webb, you've got Hubble, you've got other space telescopes. You're bringing Nancy Roman telescope online, and God knows what's going to be like when we get Vera Rubin fully going. You know, the data management and data storage requirements are just they're to some degree they're inexplicable. I mean, it's just so much data, and they'll be processing the data from the first year decades later. It's that much data. It's incredible.
It's true. It's a different approach. The Square Kilometer Array radio telescope, which is starting to be built and will, over 20 years or so, eventually work its way up to 1 square kilometer of collecting area. We hope. One of the things they're talking about is that you don't really archive anything. You just let the sky be your archive. And that's kind of like a collider. Particle colliders like the Large Hadron Collider, they watch the data as it comes in, and then if something interesting looks like it's happening, then they'll record the data and save it. But most of the time, they're just like, nope, that's boring, toss it out. So here, you might record a catalog, but you wouldn't actually record the original data, which, does, as you were saying earlier, Mary, if there's some outlier that's really interesting and you don't tell the software algorithms to look for it, you might miss it. So I do hope, and I'm glad that with Roman and Rubin, that we will be able to record all the data and you will be able to go and look at it. But it's true, the numbers were quoted for Roman in petabytes, and I had to go look up what's a petabyte again. It's 1,000 terabytes, and that's 40 petabytes, I think, is the data they expect over its 5-year primary mission.
It's incredible. And many years ago, again, I walked into a 1 terabyte drive. We had, I was working for a firm, and they had a large amount of data. They had 1 terabyte. You had to walk into a room. Now I've got down in my, in my basement, I've got 6 terabytes of storage on an array. So, we're talking petabytes now. Pretty soon we're going to be talking exabytes. And speaking of ridiculous amounts of data, one other story for this year is going to be Vera Rubin beginning science operations. And this is a big deal. This is like Vera Rubin, we talked about it a few times here, but some key aspects of its science operations. They're going to have this legacy survey of space and time, which is a decade-long survey spanning the entire southern sky every few nights to build up a dynamic, high-resolution map of the universe. It's gathering 20 terabytes of data nightly, producing 10 million alerts daily for changing objects, managed by, they've got AI brokers and whatnot managing all that. Its science goals including understanding dark matter energy, discovering hazardous asteroids, mapping transient objects like supernova and variable skies, exploring the Milky Way structure. There's an online portal for researchers to access the data. There's also going to be public availability to the data after a certain period of time. The U.S. military and I think the National Security Agency have first dibs at it because they want to take out satellite images, like images that contain satellite tracks and so on. But it's going to be just remarkable, and it's the first images were released last summer, and they were breathtaking. It was only a couple of images, and I think it's found 8,000 asteroids, of which 2,000 were new, I think was the number. It's actually Atlas, the Atlas interstellar comet that came in. They went back after it had been discovered and saw that Rubin actually captured it first, but it hadn't been yet identified as such. So this is a really big deal, and you know, astronomers are salivating, just waiting to get their hands on this data. But it's going to be a little bit like drinking from a fire hose.
Yeah, I'm not sure about the military having first access to the data. It's true it's an issue that satellite streaks, the Starlink constellations and others are a real pain for this sort of thing. And so I'm sure they're adjusting their observations to try and minimize the damage those satellites will do. But, you know, anyone uh, with the ability, with the telescope, can go look in the sky and see satellites that, you know, various governments won't tell you anything about. But yes, this is a spectacular survey in the planning for 25 years, I think. Yeah, it'll be amazing.
Well, I'll say, Professor Hall, if you ever get a chance to go there and you need someone to carry your bags, I know a really charming undergrad student who'd love to go with you.
Yeah, well, the Canada has a share, or has, I shouldn't say a share in the telescope. Canada has an agreement that will have some participation in the telescope. I've been busy with other research, but with things coming along, I should really start thinking about, okay, what might I do with some data from this telescope? Um, and I do want to say, just returning to your discussion of Roman, I did a quick check. And yes, the original mirror from Roman does date back 20 years or more, produced by the National Reconnaissance Office or something like that. But they took the mirror and refinished it and polished it. So it is now a very high quality, astronomical quality mirror from a base that the military surplus had sitting around.
Yeah, I mean those are always sort of the technical questions. So just because we're running out of time, I had one more little sort of upcoming thing, probably towards the end of this year, if everything goes well. And that's the launch of ESA, the European Space Agency's Plato mission. I've read about this a couple of times, and the description to me that sort of jumped out with this would be like the Kepler mission on steroids. Again, it's looking at sort of large chunks of the sky, looking for exoplanets. And this one is particularly geared, I think, towards finding more Earth-sized one. The original Kepler mission, because the I guess the knowledge base of exoplanets was so small at the time, they didn't really know what to gear it towards. So they were trying to find everything from sort of Earth-sized up because, there wasn't really an understanding of what the populations were like out there. So in some ways, Plato is now taking steroids with our just taking Kepler and putting it on steroids because we know what some of the populations are like and what can be found. So it's going to be quite an interesting exoplanet mission that's scheduled for launch towards the end of this year. Given technology, it might end up falling into next year, but it'll be another very interesting one. And again, probably producing vast amounts of data. I think that's sort of the common theme in a lot of astronomy, and we've seen it here tonight between Nancy Grace or Vera Rubin, is the sheer amount of data that is now being produced and that we need to, figure a way to access and store. So that's probably another thing we'll start to see over the next year or more is how do we actually sort of store, organize, and access in an efficient way the sort of massive amount of data that's going to be generated. So,
Data, data, data. It seems to be the
yeah.
story of. It seems to be the story of what's coming at us. Like I said, we better learn to start drinking from a fire hose.
Yeah, well, that is one probably good use of AI, is to try and figure out how to just sort of manage and search through some of these large data sets. Even if you just tell it to look for outliers, like I don't think otherwise you could manage these massive data sets. So that brings us, I think, to about the end of our show tonight. Again, you have been listening to the York Universe podcast produced by the students, faculty, alumni, and friends of the York University Observatory. Thank you again for listening. Clear skies, and we hope to have you back listening to our later podcasts. And again, even if you missed the live podcast, the YouTube channel has our whole catalog of podcasts, which are done almost weekly, going back for years if you are talking again about large amounts of data. So good night and clear skies from all of us.